We're going to begin going back to this worksheet. We've already done most of this worksheet. We already know how to simplify radicals. We already know that the square root of 20 is not a perfect square number. We could rewrite it with multiplication to get a perfect square number, split the root. Then we got the square root of 4, which is 2, and the square root of 5 stays the square root of 5. Not only that, guys, if you have a Casio calculator, the Casio calculator can do this for you. Why are we revisiting this worksheet? Because we kind of skipped over this fact right here, that the square root is really the power of 1/2. And the third root is really the power of 1/3. And the fourth root is really the power of 1/5, and so on, right? Whoa, I'm sorry, fourth root, 1/5. My bad, 1/4. Brain fart. The fifth root is the power of 1/5. The sixth root is the power of 1/6. Now, we're not going to do any of that today, but it's good to note because we will be doing that in the future anyway. So any square root, any radical, any third root, fourth root could be written as a rational exponent, a fraction that's an exponent. We'll get to that later. Today, we're only focusing in on this fact that the square root is really the power of 1/2. Now, that will come in handy when we have variables. Like, when you have the square root of x, we really want an even exponent right here. And let me show you why. We have example number 1, the square root of x to the 6th. We want an even exponent because the square root, we could rewrite that as the power of 1/2. And on the inside of that parenthesis, we'll have x to the 6th. And we should all know from Algebra 1 that a power to a power, you multiply those powers. So multiplying 6 times half, that's like saying 6 divided by 2, which is what? 3. So the answer is x to the 3rd. That's your answer, right? I showed my work here, but we're going to do this a couple of times, and you're going to get so comfortable with it that you're going to be able to get this answer without showing your work. But for right now, let's show our work. It'll help us understand it better. Number 2, what's the answer there going to be? You see, the square root, this square root right here, I'm going to rewrite it as the power of 1/2. So I really have 3 to the power of 2 to the power of 1/2. What do you do with the power to a power? Multiply. What's 2 times half? 1. So our answer is just 3 to the 1, which is just 3. Okay? So it's pretty simple. Anytime you have an even power, you just divide it by 2 and that'll be your answer. Right? When you have a square root. And of course, the explanation for that is because a square root's a power of 1/2. I wouldn't have even, in math, there's all kinds of angles you could look at it. I wouldn't have even done this, to be honest with you. I know that the square root of something squared, the square root and the square, they're inverse operations. They undo themselves. So the answer is clearly 3, right? It's like having a times 2 divided by 2, that eliminates, or having a plus 2 minus 2, that eliminates. The square root and the square, that eliminates. Your answer is just 3. But right now we are practicing changing the square root to a power of 1/2, so that's what I did. This guy right here, what's the answer going to be? Say again? 2 to the 3rd is the correct answer. Again, let me show my work, even though you guys already know the answer. The square root could be rewritten as the power of 1/2. What's on the inside of the parentheses? 2 to the 6th. What do you do with the power to a power? You multiply them. That would give you 2 to the 3rd. 6 times half is 3. Now, this is a problem that we could actually do. What is 2 to the 3rd? What's 2 times 2 times 2? 8. So, yeah, let's simplify it and let's say that the answer is 8. Okay? Let's move on to this one over here. Now this one, it gets a little interesting because we do not have an even exponent. We have an odd exponent. Why do we want an even one? Because this is really the power of 1/2, which means that we would like this power to be divisible by 2. But it's not. So let me just, what could I do here? Let me do a side note here. Let's go back to simplifying the square root of 20. This is a totally separate problem. Simplifying the square root of 20, that's not a perfect square number. What would we do then? Yeah, you rewrite it with multiplication to get what you want, a perfect square number, and then you split it. Okay? And the square root of 4 is 2, and the square root of 5 stays the square root of 5. That's what we used to do. That's what you should know how to do. And that's, in a sense, what we're going to be doing right here. We want a power that's even, but it's odd. I'm going to rewrite it with multiplication. So this x to the third, I'm going to rewrite that as x squared times 1 more x. Because x squared times 1 more x is really x to the third, isn't it? So I rewrote it with multiplication to get that even power, and I'm going to split the root. And now I could actually do the square root of x squared. What's the square root of x squared?
1.
X to the 1, right? X to the 1. You don't even need to write the 1. I mean, let me actually show my work just for the sake of showing my work here. We know that the square root is really the power of 1/2. And we know that on the inside we have the x squared. And we also know that a power to a power we must multiply. 2 times half is 1. That's how we get the 1 right there. But you don't really need to show the 1, so I'm erasing it again. So that's how I get the x. Now, what about the square root of x over here? You're just going to rewrite it, the square root of x. So your answer is actually x square root of x. Yay? So doing the square root of x to an even power, that should be one of the easiest things in the world. Let's just run through that real quick. X to the 12th. What's the square root of x to the 12th? X to the 6th. That's right. I could show my work, but obviously once you get comfortable, you don't need to show your work, right? What's the square root of x to the 20th? X to the 10th, right? Okay. Oh, I'm sorry. I should have put the square root. My bad. The square root of x to the 20th is x to the 10th. Okay. A lot of students get confused with this. I don't know why. The square root of x to the 16th. X to the 8th, right? It's not x to the 4th, right? Because it's not a regular 16. It's the power of 16. Okay, and the square root does become the power of 1/2, and 16 times half is 8. So I hope we understand that. The only time you actually have to do some work is when you have an odd power. We want it to be even, so what do? You rewrite with multiplication to have that even one times 1 more. So it doesn't matter what your odd number is, I would go to the number right before it. Like if this were a 13, I would say x to the 12th times 1 more x. Does that make sense? If this were a 23, I would say x to the 22 times 1 more x, right? That way it works out nicely. So check it out. Up here, we skipped over all the ones that didn't have x's. So let's look at number 5. What's the answer to x to the or the square root of x to the 4th? X to the 2, and that's it, right? Now, for the sake of showing my work, that's what I'm going to do. This square root, I'm going to rewrite it as the power of 1/2. On the inside of the parenthesis, I have x to the 4th, and a power to a power you multiply, and that's how I get x squared. That's how I got that. Obviously, once you get comfortable with this, you could just say the answer instead of showing that work. Yay? How about this guy right here? X to the 2.5. Technically, yes, but we don't want decimals up there. Okay, so what do we want right here? We want an even power, right? So let's rewrite it with multiplication to get an even power. And I always say, whatever odd number you have, go to the number right before it. What's the number right before 5? 4. So you're going to write x to the 4th times 1 more x. And now you could split the root. And now you could actually do the square root of x to the 4th. What's the square root of x to the 4th? X to the 2nd, right? And what's the square root of x? That's just the square root of x. Now maybe, and again, just for the sake of showing my work right here, I'm going to show my work. This square root, this black square root, I'm going to rewrite it as black parentheses with the power of 1/2, because a square root is the power of 1/2. On the inside of the parentheses, I have x to the 4th. And now, of course, I could power to a power multiply 4 times half. That's how I get that 2 right there. Okay? So I hope everybody understands how to do this. Let's continue. How about this one? What's the square root of x to the 6th? That's easy. X to the 3rd. Do I need to show my work? No. I mean, if you're not comfortable, yes, please show your work. But once you get the hang of it, it's just dividing that 6 by 2, because that's really the power of 1/2. That's really just dividing it by 2, so your answer is x to the 3rd. We would love having even powers in there. We don't like odds, because odds we have to rewrite it to become even. But if it's even, it's just dividing it by 2, and you're done. How about that one? What do I need to do there? It's not an even power. I don't love it. Right, okay. Yeah, let's rewrite it. Let's show our work. Instead of just saying the answer, we're going to say x to the 6 times x to the 1. I'm going to split the root. And yes, the answer that you just said, this first part is x to the third. And the second part is simply the square root of x. Okay. And if you're thinking, how did he go from here to here? Again, the work is that the square root, that's really the power of 1/2. And on the inside, you have x to the 6th. And the power 6, power of 1/2, power to a power, you multiply, 6 times half is 3. Okay? Moving on. Square root of 17. What am I going to rewrite that? Wait, I said the square root of 17. My mouth isn't saying what my brain's wanting to say. Okay, it's the square root of x to the 17th. How am I going to rewrite x to the 17th?
16.
Times 1 more x, right? And we split it. And your answer will be x to the 8th, square root of x. Ta-da. Easy peasy. Now, of course, for the sake of showing my work, explaining it to you guys, this red square root, I want to change it to a red parenthesis to the power of 1/2. Inside the parentheses, I have the x to the 16th. And now we have a power to a power, multiply. 16 times half, half of 16 is 8. That's how we got that 8 right there. All right. Let's put this paper aside. Let's get our notebooks and let's continue simplifying square roots and also expressions involving square roots. So we're going to continue with the simplifying of square roots. So how would I simplify the square root of 4x to the 4th? We no longer just have x to the 4th. We actually have a number in there as well. And you see, we know that we could split any root as long as there's no addition or subtraction going on. It's all pure multiplication. That's what we're going to do. We're going to split the root and put it on the 4 and put it on the x to the 4th. Split the root. And now you got two simple problems. What's the answer to this first problem? The nice, beautiful number 2. And how about the square root of x to the 4th? What do I have? X to the 2nd. That's it. Right? Now, again, the explanation for this guy is that that red square root is really the power of 1/2. And you put this x to the 4th on the inside of those parentheses. And of course, a power to a power, multiply 4 times half. That's how you get that 2. So the answer is 2x squared. Right? You're not going to have to show all this work once you get comfortable with it. You'll just be able to look at, oh, the square root of 4x to the 4th, that's 2x to the 2nd. Right? Let's try to do it in our heads. What if this were a 14 instead of a 4? What would the square root of 4x to the 14 be? 2x to the 7th. Good, you were able to do it in your head. That's great. That would be 2x to the 7th. But anyway, let's do a couple more simplification problems. But, of course, we're going to increase the challenge in these questions. So we have the square root of 8x to the 16th. What do I do first? Separate them, right? Put the square root on each one. Let's put the square root on the 8. Put the square root on the x to the 16th. And what is the square root of 8? It's not a perfect square number, but I could rewrite it with multiplication to get a perfect square number. What do I break it down to? 2 and 4, but let's start with the perfect square number first, 4 and 2. And then we split that root. And of course, the square root of 4, that's 2. And of course, the square root of 2 is going to stay the square root of 2. So the square root of 8 becomes 2 square root of 2. By the way, the Casio calculators could do that for you. You could type in square root of 8, hit equal, it'll tell you that it's 2 square root of 2. Okay? But what about this guy over here? The Casio calculator cannot do variables. So what is the square root of x to the 16th? X to the 8th. That's right. So our answer down here is going to be x to the 8th. Now, if you don't see that, if you're not comfortable with that yet, let's go ahead and show our work how the square root is really the power of 1/2, and inside that parenthesis you have x to the 16th, and then the power to a power multiply. That's how you get the 8 right there, right? Anyway, what we do have is 2 times the square root of 2 times x to the 8th. That is our answer, but we need to organize it. Now, what do I mean by organizing it? Oops, that's all messed up. I'm going to put the 2 and the x to the 8th together, 2x to the 8th, and I want to put the square root at the very end. So there's my final answer, organized nice and neat. 2x to the 8th square root of 2. Again, it's a long lesson, I apologize, but there's no real homework today, okay? Moving on. How about that guy, the square root of 36, x to the 9th. What do I do there? I'm going to separate that square root. We're going to have a square root on the 36 and a square root on the x to the 9th. It's like doing two simple problems. The square root of 36 is what? 6. What about the square root of x to the 9th? Right there, it might be worth showing your work right there. You don't have an even degree. You don't have an even degree. So I'm going to rewrite that x to the 9th. I'm going to rewrite it as x to the 8th times 1 more x. Okay? Split the root now, and now you could actually do this guy. What's the square root of x to the 8th?
4.
X to the 4th, right? And what about the square root of x to the 1? That's just the square root of x to the 1, just x, right? So your final answer here is 6 x to the 4th square root of x. Let's try another. What's the answer to that guy? What's the first step? Split it. So I have the square root of 50. I have the square root of x to the 25. What is the square root of 50? Is that a perfect square number? No. So I need to rewrite it to get a perfect square number. What am I going to use? Is 5 a perfect square number? Is 10 a perfect square number? So 5 and 10 doesn't work. 25 and 2. 25 is a perfect square number. And now when you split the root, you'll be able to do the square root of 25. That's just 5. And the square root of 2 is just going to come down square root of 2. Now, what about over here? We have the square root of x to the 25th. We want an even power right here, not an odd power. So I need to rewrite this with multiplication to get an even power. What's it going to rewrite as?
24.
Yep. X to the 24, the number right before 25 is 24 times 1 more x, right? Then we split that root. And now we could do the square root of x to the 24th. What is the square root of x to the 24th? It's really just dividing it by 2, right? X to the 12th. And the square root of x just comes down, square root of x. So here are my answers. 5 square root of 2, x to the 12th square root of x. And it really is all pure multiplication. 5 times the square root of 2 times x to the 12th times the square root of x. So what we could do is rearrange it, make it nicer. Let's put the nice number 5 out in the front. Let's put the nice variable x to the 12th power right next to it. And let's put the radicals, the square root of 2 and the square root of x, let's put them together underneath one square root. So that'd be 2x in there. So there is your final answer, 5x to the 12th square root of 2x. I hope you guys are understanding this. Let's try one more. That one looks crazy, but it's not. So first thing to do is to split that root to each of those terms. Instead of the square root of that whole thing, I want to have the square root of 32. I want to have the square root of x to the 16th, the square root of y to the 9th, and the square root of z to the 20th. So we have the square root of 32, x to the 16th, y to the 9th, and z to the 20th. Now let me ask you this. Out of those four, which one's like super easy to do? Which the x and the z, right? Those are easy, right? Because remember, the square root is the power of 1/2, and this is divisible by 2. So what's the answer to this already? X to the 8th, right? X to the 8th. And what about this guy over here? Z to the 10, right? Like those are like ridiculously easy, right? If you don't understand it, or if you're like kind of struggling, go ahead and rewrite the square root to become the power of 1/2. Have the x to the 16 right in there, and then recognize that a power to a power, you multiply 16 times half. Half of 16 is 8. That's how you get the 8. You don't need to show your work once you're comfortable, all right? But anyway, those are the answers so far. Let's go to the more challenging ones, which are really not that challenging. The square root of 32, it's not a perfect square number. Let's rewrite it so we could get a perfect square number. 16 times 2. Now, if you're thinking, oh, 4 and 8, yeah, 4 works. 4 is a perfect square number, but it's going to be a longer path because the 8 could be broken down again to 4 times 2. So always use the highest perfect square number possible, which in this case is 16 times 2. And of course, the square root of 16, that's the beautiful answer 4. And the square root of 2, that's just going to come down as the square root of 2. So we have that answer right there. We have this answer right here. How about the square root of y to the 9th? This is not an even degree or even power. I want it to be an even power. What am I going to rewrite this as? Y to the 8th times 1 more y, right? And then we're going to split it. And we should know now that the square root of y to the 8th is what? Y to the 4th. And what about the square root of y to the 1? That's just going to come down as the square root of y to the 1, which is just square root of y, right? So we have all of these answers. 1 answer, 2 answer, 3 answers, 4 answers. We know that all of the original questions had multiplication between them, so they still have multiplication between them. And we know that even those answers like 4 square root of 2, that's really saying 4 times the square root of 2. Y to the 4th square root of y, that's really saying y to the 4th times the square root of y. So it's all pure multiplication. So with that said, let's just organize it. We're going to put the nice number 4 out in front, then the x to the 8th, and then the y to the 4th, and then the z to the 10th. And then you take your radicals, the square root of 2 and the square root of y, and put them together underneath one square root, 2y. You know what? Probably should have stayed all with the same color. Sorry about that. Anyway, there's your answer. 4x to the 8th, y to the 4th, z to the 10th, square root of 2y. Yay? Okay. So that is simplifying, and that's as complicated as simplifying a single square root could be. But we're also going to be able to simplify expressions, math expressions, that have square roots within them. And I'm just going to compare that to what we did in pre-algebra, right? Everybody knows that 2x plus 3x, let's say, oh, I got 2 apples and I got 3 more apples. That's a total of 5 apples, right? It works the same with square roots. What do you think 2 square root of 5 plus 3 square root of 5 is?
5.
Yeah, 5 square root of 5. Easy peasy, right? How about, could I add, back in Algebra 1, 2x to the 3rd plus 3x squared? The answer is no. Why not? Because these are not like terms. This is 2 of something plus 3 of something else, right? You got 2x, that's like saying 2 apples plus 3 oranges. You don't have 5 up oranges, right? Like they're just, you can't add apples and oranges. You can't add x to the 3rds with x to the 2nds. You can multiply them, but you can't add them. So similarly to that, when you have square roots that are different, you cannot add them. You can't say, oh, I got 2 square roots of 5 and I want to add 3 square roots of 7. They're not like terms. You cannot add them. Does that make sense? Okay, so I just want to relate everything to pre-algebra, to Algebra 1 stuff. Let's go to this example right here. We could multiply, though. They don't have to be like terms to multiply. Right here, you have 2 times 3, that's 6. And what about x to the 3rd times x to the 2nd? What's that? X to the 5th, Algebra 1 stuff, right? So there's your answer. You don't have to have like terms to multiply. Same thing here. You don't have to have the same square roots to multiply, right? You could multiply the 2 times 3 and get 6. And right here you can multiply square root of 5 times square root of 7 and get what? 35. Yes, you're supposed to try and simplify 35, but you can't, right? 35, you can't break it down with multiplication to get a perfect square number. So there's your final answer there. So I just wanted to show you the similarities between what you already know and doing those math operations with square roots. So if you understood what I just explained, could you guys tell me what the answer to number 1 will be right here? What's 2 plus square root of 3? You can't say 2 square root of 3 because that would imply that you actually added them together, right? Or put them together. You just leave it exactly the way it is. It's already simplified. 2 plus square root of 3. Okay? You can't do it. It's already simplified. It's like saying, if I say 2 plus x, what's your answer? It's not 2x. It's just 2 plus x, right? How about here? I got 3, let's say x plus 1 more of those x's. What's your answer there going to be? Okay, we're missing it here, guys. We're missing it here. Look, if I imagine a radical is kind of like an x. The square root of 2, imagine 3x. What's 3x plus 1 more x? 4x. In this case, what? 4 square root of 2. Yes? No?
Yes.
Okay. How about this guy over here? Could we add those? No. Well, not yet. Because they're not like terms, right? It's like you got 5 apples and you want to add like something else. 5 apples plus 1 pencil. I don't know. You can't really do that yet. But what if it turns out that that pencil is really an apple? What? Okay. Now, what do I mean by that? Check this out. The square root of 8, I could actually simplify the square root of 8. I could rewrite that to 4 times 2. I could square root. I will have 2 square root of 2. And now I could take this 5 square root of 2 and I could add it with the 2 square root of 2 because now they are 5 apples plus 2 apples. Now they really are the same radical, giving you the final answer, 7 of those apples, 7 of those square roots of 2. I hope this makes sense. And by the way, any math with just radicals, with just square roots, the calculator Casio that I have at my desk could do them for you. As long as there's no variables involved, like x squared or y's or, that. So you could actually do this on the calculator. Let's take a look at not just adding and subtracting, but how about multiplying? We have the square root of 2 times the square root of 8. We could multiply those together. What do I get? And what is the square root of 16? 4. Thank you. That's a little harder than what I thought, right? Number 2. Could I multiply those? Heck yeah. What's my answer going to be?
6.
Yep, 2 times 3 is 6. And then the square root of 3 times the square root of 2, you multiply those together and you get the square root of 6. And yes, you're supposed to try to break this down, but you can't. So there's your final answer, 6 square root of 6. Again, the calculator could do this for you. How about the square root of 7 times square root of 7? Square root of 49. But what is the square root of 49? 7. And that brings up something very important. When you multiply a square root with itself, the square root disappears. Yay? Okay, what's the square root of 3 times square root of 3?
9.
The square root of 9, but what's the square root of 9? 3. You see, you don't have to show this part. Whenever you multiply a square root with itself, the square root disappears, right? If I say, what's the square root of 7 times square root of 7?
7.
That's just 7. If I say, what's the square root of happy face times the square root of happy face? That's just happy face. Okay? Do we get it? Cool. Almost done. Let's distribute with square roots. Let's distribute with square roots. You might want to jot this down. The square root of 2 times the binomial 3 minus 4 square root of 5. Well, you take the square root of 2 and distribute it. Remember, a square root is kind of like an x, right? If you have x times 3, what's your answer? 3x, right? In this case, square root of 2 times 3, what's your answer? 3 square roots of 2. Now, how about when I distribute it over here? The square root of 2 times negative 4 square root of 5. What's that going to be? Negative 4 square root of 10. You multiply the numbers. There's a 1 times 4 or minus 4. That's minus 4. And then the radical 2 times the radical 5 is 10. And could we combine these? No, because they're not like terms. You got square roots of 2, you got square roots of 10. I hope we understand that. Let's try something that's a little bit more challenging. Right here we have a binomial times a binomial, and we're going to distribute. Check it out. What is 3 times 4? 12. What is 3 times 3 square root of 5? Which is kind of like 3 times 3x.
6.
3 times.
9.
Yeah, 9, not 6. And we have square root of 5 with it, right? Okay. 3 times 3x is 9x. 3 square root of 5 is 9 square root of 5. Now let's distribute the minus 2 square root of 2 times 4. What do we get there? Minus 8 square root of 2. That's right. And how about minus 2 square root of 2 times 3 square root of 5? Negative 6 square root of 10. That's right. That's your answer. And yeah, you're supposed to try to combine like terms, but none of them are alike. You're supposed to try to break this down to get a perfect square number, but you can't. So believe it or not, that's your long, disgusting answer. All those 4 terms. Now, not all your answers are going to be long and disgusting like this. Sometimes you get beautiful answers. Check this one out. This next one is amazing when it comes to distributed property. Let's distribute. What is 3 times 3? 9. What is 3 times square root of 2? Plus 3 square root of 2. Okay. What is negative square root of 2 times 3? 3 square root of 2. Okay. And what is negative square root of 2 times positive square root of 2? A negative times a positive is a negative. You know what? Let me do this in blue. Right. Oh, I messed that up. Like that. Okay. So I have a negative. And what's the square root of 2 times square root of 2? Square root of 4. Right? So now, could we combine any of these?
Yes.
Which ones? This one and that one are exact opposites. What happens?
They
Cancel out. So what do we have here? We have a 9 minus square root of 4. But what is the square root of 4? This is 2. Right? So 9 minus 2 is 7. Crazy. Believe it or not, this nasty looking problem ends up being the nice, beautiful answer 7. Now, what could you tell me about the original problem? What's your observation with those binomials?
That one was a function and one was negative.
One has a plus, one has a minus. That's exactly right. It's the same identical binomial, but the signs of the second term got changed, right? And that is the definition of a vocab word I want you to remember right now. The word is called conjugate. Conjugate, right? Conjugate. Write that down. So what is a conjugate? Let's first understand what it is. It's the same binomial, but change the sign of the second term, the middle sign, right? If it's a plus in the middle, change to a minus. If it's a minus in the middle, change to a plus. Let me actually write down any binomial. Let's see, give me a number. Any number? 5. Minus square root of, what it was? 3. Okay, 5 minus square root of 3. Okay, conjugate is, what's the conjugate of 5 minus square root of 3? 5 plus square root of 3. Believe it or not, that's going to be a question on the quiz. But anyway, yeah, that's the conjugate. So you know what a conjugate is, but let's now learn and understand why we love conjugates when we're multiplying. And maybe these notes are a little too much. It says multiplying a binomial, this is a binomial, that has a rational number, that's a rational number, being added or subtracted to a square root term, there it is, subtracted to a square root term, multiplying it with its conjugate, multiplying it with this, will result in a rational answer, a nice number with no square root. Maybe, instead of writing all that stuff in blue, you could just say, if I multiply a binomial with its conjugate, I get a nice answer. Because that's what it is. If I write a binomial, the one you just gave me, and multiply it with its conjugate, I want to get a nice, beautiful answer. Watch this. 5 times 5, 25. 5 times square root of 3 is positive 5 square root of 3. But then, a minus square root of 3 times 5, that's a minus 5 square root of 3. And a minus square root of 3 times a positive square root of 3, that's a minus square root of 3 times square root of 3 is a square root of 9. Yay? So, could I simplify that? Could I combine anything? Yeah, the middle terms. What happens here and here? Cancel out. So I have the nice, beautiful number 25. I have the minus sign. And what about the square root of 9?
3.
That's 3, right? So I just really have 25 take away 3, giving me 22 as my final answer. So anytime you have a binomial and multiply it with its conjugate, you get a nice, beautiful answer. And we're going to use that in the future. It also works with imaginary numbers. We're going to talk about complex conjugates tomorrow. But for right now, this is all I wanted to cover today on the first day back from Thanksgiving. I hope we understand what we just did. Homework, watch the video again so it'll make more sense to you when we come back tomorrow.